Chances are you're pretty familiar with the idea of erosion, when water and air slowly strip away layers of soil and rock. However, how could air and water cause such dramatic landscapes like canyons and fjords from seemingly solid rock? The answer is relatively simple. Weathering wears down these otherwise solid structures, making it much easier for other processes to change a landform. In this lesson, we're going to look at the 3 types of weathering and their causes. Finally, we will examine how rates of weathering can change and how their impact on landforms is of great interest to humanity. But first, the 3 types of weathering: physical, chemical, and biological. Physical weathering occurs where there are physical changes to the landform's rocks or soil. While we may think of rock as pretty solid, it is actually full of tiny cracks and crevices. Water fills up these cracks and crevices and expands and contracts with changes in temperature. When water freezes, it forms ice crystals that are actually pretty hard. On a molecular level, these ice crystals weaken the bonds of the rocks. Also, erosion can cause a slippery slope when it comes to weathering. Let's say that there is a solid rock surface where the force of the rock pressing down is equal at any point under the landform. Then erosion comes along. As anyone who has seen the effects of erosion at places like the Grand Canyon can attest, erosion is not an even process. It leaves ridges and valleys on the landform itself. Since there is less mass of material pressing down, these ridges and valleys are pushing up by geological forces far underground. In turn, these ridges and valleys provide new opportunities for water to freeze and thaw, as well as for other forms of weathering. Chemical weathering occurs when a chemical reaction causes a change in the landform's geological profile. Take a hill that has considerable amounts of iron ore. If other factors expose that iron ore, a chemical reaction can occur between the iron and air, creating rust. Iron may be a very solid material, but rust can be brushed away with a firm brush. As a result, rust is easily pushed away by water and air, leaving space where there was once solid iron ore rock. Many types of chemical weathering are increased in strength when rainwater is more acidic. This has become increasingly common due to elevated levels of pollution. The more acidic water leaches into landforms and reacts with the minerals that make up a given area. The reaction is especially dramatic when acidic rain affects limestone, a common layer for many landforms. Finally, there is biological weathering, which is weathering caused by a living organism. Remember, weathering does not remove the material in question, so humans mining and quarrying materials is not an example of biological weathering. Instead, think of moss growing on a rock. These creatures produce chemicals that help to break down the rocks that they grow on. Likewise, a plant growing through cracks in a rock will eventually cause more splits to develop in the solid material. Since weathering can fundamentally change the nature of a given landform, it is therefore of great interest to humans. Likewise, the ability to measure changes in weathering rates is also of vital importance. As you may have gathered, the presence of rain and varied temperatures can have a major effect on weathering. However, there are other factors as well. The composition of the rain in question also has an impact. Less acidic rain from places with strict environmental guidelines is less likely to cause weathering than rain from places with higher instances of pollution. Further, the type of rock plays a significant part. Iron will not break down as quickly as limestone due to acid rain, while limestone will not rust. In this lesson, we learned about weathering, which wears down otherwise solid structures, making it much easier for other processes to change a landform. We explored the 3 types of weathering, as well as what causes them and how weathering rates can change. Physical weathering occurs when there are physical changes to the underlying geological structure of a landform. Chemical weathering occurs when chemical reactions cause changes to the geology of a given location. Finally, biological weathering is when an organism accelerates the process of weathering. Numerous factors influence rates of weathering, from the type of rock being weathered to the environmental regulations of nearby communities.